some of the key pieces of information, such as the x-intercept, the axis of symmetry, the x-coordinate of the vertex, etc. And to do that by making a table. We talked about different ways to make tables. I made a video yesterday kind of showing you how to do the tables again using the A, H, and K. But you can always make a table just going back and plugging in values the way we used to make tables. The only flaw to making your table that way is that it doesn't allow you to get the vertex as your first key point. So again, the idea for the table is it's x plus h, and if h is negative, then it's minus h. Ya plus k, or if k is negative, then it's a minus k. So you can kind of see down here in the table, my h value is 3. So I add 3 to 0, 1, and 2. My a value is 1, so I multiply everything by 1. And then my k value is negative 1, so I subtract negative 1 away from each of those. So again, the idea is that you kind of have to play off of whatever your A, H, and K are. This is in vertex form, so the y-intercept isn't easily seen. The y-intercept occurs when x is 0. So you could plug 0 in. 0 minus 3 is negative 3. Negative 3 squared is 9. 9 minus 1 is 8. So my y-intercept is 0, 8. The axis of symmetry, I noticed on some of your homeworks when I was checking them yesterday, the axis of symmetry has to be an x equals equation. The axis of symmetry has to be an x equals equation. So you need to make sure you have x equal on your axis of symmetry. A lot of you had the axis of symmetry correct, but you are missing the x equals. Okay? Any questions on graphing a quadratic? I'm going to be sending you the answer keys to the homeworks for day 1, 2, and 3, so that I'm going to send those tomorrow, so you can use some of our class time tomorrow to check them. And then if you have any questions on them, I will gladly go over them Thursday in class. So I'm going to give you some opportunity to check the homework that you have turned in recently and use some of the class time on Thursday to answer any of those questions. We are moving into section 5.2 today. 5.2 is solving quadratics by graphing. So our focus is still on graphing. It's just that now we're looking at graphing and solving simultaneously. So that's why 5.1 was so important. So there is some new vocabulary that comes along with this. So the word solution can also be referred to as the roots or the zeros of a quadratic function. The word solution can also be referred to as the roots or the zeros of a quadratic function. The quadratic term is ax squared. Bx is our linear term, and c is the constant. The highest exponent is 2, therefore the degree is 2. When solving a quadratic, the very first thing you need to do is get it set equal to 0. When solving a quadratic, the very first thing you need to do is get it set equal to 0. Wherever the quadratic equals 0 will be our roots or solutions. And graphically, these are called the x-intercepts. So graphically, the roots or solutions are our x-intercepts. So there are 3 different cases that can happen with a quadratic function. You can have a case of no solution, one solution when the vertex is on the x-axis, or 2 solutions where the quadratic crosses the x-axis twice. So quadratics can have no solution, one solution, or 2 solutions. So here is a graph of x squared minus 4. That graph is shifted down 4 units. And what we notice is it crosses the x-axis twice. So the roots occur when x squared minus 4 equals 0. So if that gives the roots, we can also see that graphically, and we notice on the graph that occurs at this point here and that point there, which are the coordinates -2, 0 and 2, 0. So my roots occur at -2, 0 and +2, 0. Those are my solutions or roots. You can check it by plugging -2 in. -2 squared is 4. 4 minus 4 is in fact 0. In section 3, we're going to talk about factoring this, so you might already be thinking that in your head, but that's section 3. For now, we're going to get it off of our graphs or from a table. Okay, so here we have -x squared plus 2x. So this graph is reflected. It is shifted up 1 unit and to the right 1 unit. So we can see that based off our vertex. So again, looking at the graph, the roots are at x equals 0 and x equals 2. So the roots are at x equals 0 or x equals 2. As x-intercepts, we label these as the points 0, 0, and 2, 0. So roots, you usually give it in terms of an x equals. As intercepts, we give it in terms of coordinate points. If a graph is a little bit more difficult and you can't necessarily see your roots without the graph being given to you, then we can find our graph. So this is in standard form. The y-intercept is 0c. So I know I have a point at 0, 8. I find my h and k. So h is -b, so that's -6 divided by 2a, which is just 2 times 1. So -6 divided by 2 is -3. So my h value is -3. I need to use that h value to find k. So k occurs when we plug -3 in. -3 squared is 9. Negative 3 times 6 is negative 18. And adding 8. So 9 plus 8 is 17. 17 minus 18 is negative 1. So my K value is negative 1. So what that means is my vertex is negative 3, negative 1. My axis of symmetry is x equals negative 3. So that means my table starts with negative 3. And then again, the idea is that's like 0 plus h. So then the next point would be 1 plus h. So 1 minus 3 is negative 2. Then 2 minus 3 is negative 1. And then 3 minus 3 is 0, and that would continue. The y would be ya plus k. So 0 times 1 is 0, plus k is negative 1. 1 times 1 is 1. 1 minus k, or 1 minus 1 is 0. And 4 times 1 is 4. And 4 minus 1 is 3. And then this would be, so it goes 0, 1, 2, 3. This goes 0, 1, 4, 9. So it'd be 9 times 1, which is 9, minus 1, which is 8. And we can see my y-intercept is in my table. Plotting those points, you have negative 3, negative 1, negative 2, 0, negative 1, 3, 0, 8. And remember that any point on here is symmetric. So if it goes up 1, right 1, it goes up 1, left 1. If it goes up 4, right 2, it goes up 4, left 2. Up 9, right 3, up 9, left 3. Connecting our points, we see our quadratic. We also see once again that the quadratic has 2 roots. One of them is at negative 2, 0. And then the other one is at negative 4, 0, which we can see from our graph. So your roots are at x equals negative 2 and x equals negative 4. Okay, so the bell is going to ring at 10:05. What I want you to do for your homework is that next page, you're going to do the front and the back of it. The front is identifying them, the back is graphing. So I think at this point we're pretty good at graphing. Tomorrow, I'm going to do examples 2 and 3 for you and put them out there as a video. So tomorrow, my video will be examples 2 and 3. And then I actually have a quick delta math you'll do too, just on finding roots. But it'll be just a few questions. So the video will be on delta math for you, so you don't have to hunt it down. It'll be embedded like it was last time. So the homework assignment isn't due till Thursday. The delta math will be assigned tomorrow, yeah? Because tomorrow is our Wednesday.